Hello everyone, welcome back to my channel. I am Ranjit GS, a CSC student from Sri Venkateswara College of Engineering, Bengaluru. Currently I am studying in second semester. Now in this video we are going to discuss a topic which is related to computer aided engineering drawing. Now let us see the contents. We will be studying in this video about the introduction to solid-state software for CAD and the Cartesian coordinate system and the reference planes, that is HP, VP, RPP, LPP of 2D or 3D environment. Now firstly let us see the introduction to solid-state software. SolidEdge is a powerful computer-aided engineering drawing software developed by Siemens PLM Software. It offers comprehensive 3D modeling, simulation, and manufacturing capabilities for designing and engineering products. SolidEdge is widely used in various industries, including automotive, aerospace, machinery, and consumer goods. Now let us see some of the key features of SolidEdge software. First one, solid modeling. SolidEdge allows user to create and modify 3D solid models with easy, enabling accurate representation of real-world objects. Second one, assembly design. With SolidEdge, users can create complex assemblies and test their functionality, ensuring proper fit and function of components. Simulation and analysis. The software provides simulation tools to analyze and validate designs, enabling engineers to optimize product perform reliability. Now let us see the advanced functionality in SolidEdge software. First one, sheet metal design. SolidEdge offers dedicated tools for designing sheet metal parts, including bending, flattening, and unfolding features. Second one, electrical design. The software includes capabilities for designing electrical systems and integrate them with mechanical components. Third one, 3D printing support. SolidEdge supports the design and preparation of 3D printable models, facilitating rapid prototyping and production process. Now let us see how to set up the sheet where we are going to work in the CAD software. Firstly, open the CAD software. Then, then you will see the window like this. Then click on the drawing option. Now click on the sheet option which is present at the bottom left side. Now you will see a window like this. Then click on the background and select A4 sheet and switch off the show background. Then click on save defaults and select OK. Then the sheet will appear like this. Then click on the fit option which is present at the top, which is highlighted. Now let us see the tools which we are going to use in the CAD software. First, line tool, which is used to draw the lines and which can be also used to mark the points in the worksheet. And the second tool is used to draw the curved lines in the sheet. And the third tool is used to cut the arcs. And the fourth tool is used to draw the circles at particular diameter which we required. And the fifth tool is used to draw the squares, rectangles at particular dimensions. And the trim tool is used to trim the lines or any other portions which we are not required in the drawing. And the move tool is used to move the lines or any other blocks which are present in the drawing from one place to another place. And the select option is used to select the lines or any blocks which are present in the drawing. And the measuring tool is used to measure the length of the line or diameter of the circle, etc. And this measuring tool is used to measure the angles between the two lines. And the text option is used to add the text in the sheet. And the leader tool is used to plot the arrows where required. And at the top there is a zoom option which can be used to zoom the sheet. And at the left side of the zoom option there is a magnifier option which can be used to magnify the required positions or portions in the drawing. Now let us see the Cartesian coordinate system in CAD. Cartesian coordinate system. The Cartesian coordinate system is a fundamental tool used in computer-aided engineering and design. It provides a way to represent points, lines, curves, and surfaces into a 2 or 3-dimensional space. By using X, Y, and Z coordinates, CAD software can accurately define and manipulate objects within a virtual environment. Now let us understand the coordinate plane. The coordinate system consists of two perpendicular axes, namely x and y, which intersect at the origin. The x-axis represents the horizontal direction, while the y-axis represents the vertical direction. Any point on the coordinate plane can be uniquely identified by its x and y coordinates. And in the first quadrant, both x and y are positive. And in the second quadrant, x is negative and y is positive. And in the third quadrant, both x and y are negative. And in the fourth quadrant, x is positive and y is negative. Now let us see extending to 3 dimensions. In 3 dimension CAD, an additional z-axis is introduced perpendicular to x and y axis. The z-axis represents the depth or height of a height dimension. The z-axis represents the depth or height dimension. Points in this system can now be represented by 3 coordinates, allowing for more realistic and complex designs. Now let us see the coordinate transformations. Coordinate transformations in CAD involve translating, scaling, rotating, and mirroring objects within the Cartesian coordinate system. Translation involves shifting an object's position along the x, y, or z axis. Scaling changes the size of an object uniformly or along specific dimensions. That means we can shift the objects which are present in the drawing from one place to another place, or we can rotate those objects, or we can scale that objects. Rotating involves rotating an object around a reference point or axis. Mirroring flips an object across a specific line or plane. These transformations enable intricate manipulations of objects in CAD, facilitating the creation of complex designs. Now let us see the benefits of using coordinates transformation. The use of standardized coordinate system simplifies communication between designer, engineer, and manufacturers. CAD software ability to manipulate objects within the Cartesian coordinate system saves time and resource during design iterations. The precise nature of the coordinate system ensures accuracy and precision in the decision process. Now let us see the limitations and challenges of coordinate system. The Cartesian coordinate system assumes a flat Euclidean space which may not accurately represent some real-world scenarios. Complex designs with intricate curves or irregular surfaces may require advanced mathematical techniques for accurate representation. The accuracy of design with the Cartesian coordinate system is limited by the CAD software and hardware. Now let us see the reference planes, that is HP, VP, RPP, LPP of 2D or 3D environment. Now let us see the introduction to HP, VP, RPP and LPP. HP, VP, RP, LPP are reference planes used in 2D or 3D environments. HP stands for horizontal plane and represents the ground or floor level. VP stands for vertical plane and represents the vertical surface or walls. Now let us see the horizontal plane, that is HP. HP is a reference plane parallel to ground or floor level. It helps define the base or foundation of a 2D and 3D environment. Objects placed on HP appear flat and do not have any depth. Now let us see the vertical plane, that is VP. VP is a reference plane perpendicular to the ground or floor level. It represents the vertical surface or walls in a 2D and 3D environment. Vertical plane helps create depth and perspective in the design or visualization. Now let us see the definition of right profile plane. Right profile plane is another reference plane utilized in CAD. It represents the right side of an object or system. It helps in visualizing and analyzing the right side of a design. Now let us see the LPP, that is left profile plane. Left profile plane is a reference plane used in computer-aided engineering and drawing. It represents the left side of an object or a system. It helps in visualizing and analyzing the left side of a design or a drawing. Now let us see the differences between left profile plane and right profile plane. Left profile plane focuses on the left side of the design, while right profile plane concentrates on the right side. Both planes are necessary for a holistic understanding and effective engineering of a system or object. They ensure uniformity, balance, and ease of use in final product. Now let us see the reference planes that are HP, VP, RPP, LPP in 2D dimension. In 2D design, HP represents the base or the ground level of the composition. VP helps create depth by indicating the vertical surface or walls. RPP and LPP techniques are used to create a sense of perspective and realism. Now let us see the HP, VP, RPP and LPP in 3D dimension. In 3D design, HP represents the floor or ground level of the virtual space. VP defines the vertical surface or walls in the 3D environment. RPP and LPP techniques are essential for creating depth and realistic views. Now let us see the practical applications of CAD. HP, VP, RPP, LPP are used in horticultural and in interior designs. They aid in creating accurate floor plans and elevations. These reference planes also help in visualizing 3D models and animations. Now let us see the importance of reference planes. HP, VP, RPP, LPP provide a framework for organizing and understanding space. They help maintain consistency and proportion in design compositions. Reference plane enhance the visual appeals and realism of 2D and 3D environments. Thank you. Thank you for watching the